The James Webb Space Telescope, JWST, a powerful tool from NASA, has been peering into the vast depths of the universe, uncovering incredible revelations. While previously it was focused on the exploration of minuscule objects, its latest discoveries have shaken the scientific community. These findings are so substantial that they could challenge our entire understanding of the cosmos, compelling experts to rethink our current theories and possibly altering everything we believe about the universe. When we speak of the edge of the universe, we are often referring to the observable universe, the part of the cosmos that we can see and study using telescopes and other advanced space probes. This realm contains galaxies, stars, and countless celestial objects, but the observable universe is only a tiny fraction of the entire universe. It's like a slice of a giant pie, one that we're only beginning to explore. The true scale and shape of the entire universe remain a mystery, and the observable universe, though vast, is only about 93 billion light-years across. A light-year, the standard measurement of distance in space, is the distance that light, the fastest known entity, travels in a single year. This distance amounts to about 5.88 trillion miles or 9.46 trillion kilometers. So, when we say that the observable universe is 93 billion light-years wide, we're speaking of a colossal span that reaches back to nearly 13.8 billion years ago. This is when the universe began with the Big Bang, a massive explosion that set the universe into motion. Since then, the cosmos has been expanding, and this expansion continues at an accelerating pace due to the mysterious influence of dark energy. Over time, matter in the universe has coalesced under the force of gravity, forming galaxies, stars, and planets, including our own Earth. Despite the enormity of the universe, much of it remains empty. If we could shrink the Earth to the size of a coin, the nearest star would still be about the length of 2 soccer fields away. The void only deepens within our own galaxy, the Milky Way, which is just one of billions of galaxies within the observable universe. This scale helps us grasp the vastness of space, which can be overwhelming to comprehend. You might wonder why we can't see everything that exists in the universe. The answer largely involves light. Even though it travels incredibly fast, light takes time to traverse the vast distances of space. Therefore, when we observe distant celestial bodies, we are actually seeing them as they were in the past. The farther an object is, the longer its light takes to reach us, and it's almost like peering through a massive time machine. For instance, when we gaze at galaxies millions or billions of light-years away, we are essentially looking into the universe's past. Moreover, the universe itself is expanding. Think of it as an inflating balloon. As the balloon inflates, spots on its surface move further apart. Similarly, as the universe expands, galaxies drift away from each other. This expansion stretches the light emitted by these distant objects, causing what is known as redshift, where the wavelengths of light become longer, making the objects appear redder. This phenomenon occurs because the space between the objects and us is increasing. Given the speed of light, the expansion of space, and the ongoing growth of the universe, it's no surprise that we haven't been able to observe everything that the universe contains. Even with our most advanced telescopes, our view of the cosmos is still constrained by these fundamental properties. The quest to understand the true boundaries of the universe has intrigued scientists for years. Several competing theories have emerged, each offering different insights into the nature of the universe's size and structure. The first theory suggests that the universe may be infinite, extending forever in all directions without a clear edge. This theory aligns with the cosmological principle, which holds that the universe looks the same from every viewpoint. If this theory is correct, then the universe is limitless in all directions with no boundaries to its expanse. A second theory offers a different perspective. It proposes that while the universe may have a limit, it might not have a clear-cut edge. Instead, the universe could be shaped like a giant sphere or a curved space, meaning that if one were to travel in a straight line long enough, they would eventually return to their starting point, similar to how a journey around Earth would bring you back to where you began. The third theory, known as the multiverse hypothesis, posits that our universe is just one of many. In this scenario, there could be countless other universes, each with its own set of physical laws and properties. These universes could be vastly different from one another or could be connected through complex interactions, forming an even larger and more complicated multiverse. The James Webb Space Telescope, JWST, has been instrumental in providing insights into these cosmic mysteries. As NASA's latest tool for exploring the universe, the JWST is capable of peering deep into space with unprecedented precision. One of its most remarkable achievements has been the discovery of 6 enormous galaxies dating back to just 500 to 700 million years after the Big Bang. These galaxies are significantly larger than expected for such an early period, challenging previously accepted theories about the formation of galaxies. Their intricate structures and massive sizes suggest that galaxy formation might have occurred much more rapidly than previously believed. The JWST's ability to capture infrared light, which is invisible to the human eye, allows it to detect faint signals from ancient stars and galaxies. This capability is like a time machine, offering a glimpse into the early universe. The telescope's findings have revealed galaxies that appear to defy our previous understanding of cosmic evolution, suggesting that they may have formed much faster than expected after the Big Bang. These galaxy breakers challenge the theory that galaxies form slowly over time. Traditional models propose that galaxies begin as small, simple collections of stars that gradually evolve into more complex systems. However, the JWST's discoveries have shown that some galaxies appear fully formed much earlier than anticipated. This has forced scientists to reconsider the process by which galaxies develop, especially considering how such large, complex galaxies could form so quickly after the universe's inception. The data collected by the JWST also uses spectroscopic methods to study light across various frequencies, unlocking further details about these galaxies, such as their composition, size, and distance from Earth. By analyzing the light emitted by these distant galaxies, scientists can piece together the history of the universe itself. The recent revelations from the JWST have revolutionized our understanding of the universe, revealing a more complex and diverse cosmos than we had ever imagined. The discoveries made by this advanced telescope not only challenge existing models of galaxy formation, but also offer exciting new possibilities for our understanding of the cosmos. One of the most significant breakthroughs is the identification of the oldest and most distant galaxies ever observed. These galaxies date back to a time when the universe was still in its infancy, only a brief period after the Big Bang. These findings highlight the JWST's remarkable ability to look far back in time and study the early stages of the universe. Despite the impressive discoveries made by the JWST, much of the universe remains hidden from view. There are still vast stretches of space that we have yet to explore, and even with the JWST's cutting-edge capabilities, there is still much to learn about the universe's history and future. The telescope has given us a new window into the cosmos, but there is still so much more to uncover. As we continue to explore the universe through the JWST, we are reshaping our understanding of the cosmos. The telescope's groundbreaking findings are challenging our established ideas about the universe and forcing us to rethink fundamental questions about its origin, structure, and ultimate fate. The discoveries made by the JWST will undoubtedly have a lasting impact on our knowledge of the universe for years to come, offering new insights into the nature of space, time, and the universe itself. The James Webb Space Telescope continues to astonish the scientific community with its groundbreaking discoveries, providing humanity with an unprecedented look into the depths of space. As we uncover more details about the early universe and its evolution, the JWST is playing a critical role in transforming our understanding of the cosmos. Its ability to observe distant galaxies, stars, and other celestial objects in greater detail than ever before is unveiling mysteries that were previously beyond our reach. What makes these discoveries even more profound is the ability of the JWST to provide a window into the very beginnings of the universe. By capturing light from galaxies that formed just a few hundred million years after the Big Bang, it allows us to study the early stages of cosmic evolution in real time. This opens up a new realm of possibilities for understanding the formation of the first stars, galaxies, and other structures that would ultimately lead to the universe we know today. One of the most intriguing aspects of the JWST's discoveries is its ability to uncover the true scale and complexity of the universe at an early stage. The vast galaxies that have been discovered, some far larger and more intricate than anticipated, challenge the conventional wisdom that galaxies grow gradually over billions of years. Instead, we are now confronted with the possibility that these massive structures could have formed rapidly in the early universe, suggesting a much more dynamic and complex process of galaxy formation than previously thought. This newfound complexity pushes the boundaries of current scientific models and forces us to reconsider our theories about dark matter, dark energy, and the forces that shape the universe. As we learn more about the rapid development of these early galaxies, scientists will be required to revisit our understanding of physics, particularly the behavior of matter and energy in the early universe. The JWST is providing the tools necessary to investigate these fundamental questions in ways that were previously unimaginable. As the James Webb Space Telescope, JWST, continues its mission, it is poised to uncover even more profound insights that will not only challenge existing models but potentially reshape our understanding of fundamental physics. One of the most groundbreaking aspects of the JWST's observations is its ability to capture the faintest signals from the very early universe, long before the first galaxies and stars formed. By peering into this earlier epoch, the telescope can observe a time when the universe was still in a primordial state, providing a glimpse into the earliest stages of cosmic evolution. This capability opens a window into the formation of the first black holes. Although black holes are well known to exist today, their origins remain a mystery. The JWST's ability to study distant, young galaxies may provide clues about how the first supermassive black holes formed and how they influenced the surrounding galaxies. Astronomers are keenly interested in these early black holes because their formation could hold the key to understanding the interplay between dark matter, dark energy, and the growth of galaxies. These black holes could have been among the first objects to begin altering the fabric of the universe, affecting the surrounding gas and influencing galaxy formation processes. By observing the high redshift galaxies and the early cosmic structures that the JWST is uncovering, scientists hope to discover how these mysterious objects first came into existence and how their presence shaped the early universe. Additionally, the JWST's findings are also contributing to our understanding of the formation and distribution of heavy elements in the cosmos. Elements like carbon, oxygen, and nitrogen, which are essential for life as we know it, were formed in the cores of stars. However, understanding the distribution of these elements and how they came to be present in the universe has been a challenge. By studying the light from distant galaxies, the JWST is helping scientists map the abundance of these elements across different regions of space and time. This knowledge is essential for understanding not only the history of the universe but also the conditions required for life to emerge elsewhere. The presence of heavy elements in distant galaxies provides critical clues about the chemical evolution of the cosmos and how the first stars seeded the universe with the building blocks of life. Another exciting area of investigation for the JWST is the study of exoplanets, particularly those that lie in the habitable zone of their parent stars. The telescope's advanced instruments are capable of analyzing the atmospheres of these exoplanets with unprecedented sensitivity, allowing scientists to detect the chemical composition of their atmospheres and identify potential signs of habitability. The ability to detect molecules such as water vapor, methane, or carbon dioxide could indicate the presence of conditions suitable for life. The discovery of even small, Earth-like planets orbiting stars in the habitable zone of their solar systems is an area of significant interest. By investigating these distant worlds, the JWST is helping to answer one of humanity's most profound questions. Are we alone in the universe? This research could lead to the identification of planets that not only have the right conditions for life but could also provide further insight into the potential for life beyond our own solar system. Moreover, the JWST is revolutionizing our understanding of galaxy evolution. Traditional models suggested that galaxies formed and evolved over billions of years, gradually becoming more complex structures as stars were born and died. However, the telescope's observations of galaxies in the distant past have revealed something unexpected. Many of these early galaxies appear far more mature and massive than previously thought. This challenges the established understanding of how galaxies evolve over time, suggesting that some galaxies may have undergone rapid growth early in the universe's history. Understanding this process is critical for refining our models of galaxy formation and learning how these early structures led to the complex galaxies we see today, including our own Milky Way. The JWST is also expanding our understanding of cosmic inflation, the period of rapid expansion in the very early universe, just after the Big Bang. The discovery of new and unexpected cosmic structures in the deep past provides further evidence for the theory of inflation, which suggests that the universe expanded exponentially within the first fraction of a second after the Big Bang. By studying the faint light from this era, scientists are gaining new insights into the forces that shaped the early universe and the cosmic microwave background radiation that permeates all of space. These observations may help refine our understanding of the physics of the early universe and the forces that drove its rapid expansion. As we continue to gather data from the JWST, it is becoming increasingly clear that our current understanding of the universe is just the beginning. The telescope's ability to investigate the farthest reaches of space, explore the formation of galaxies, black holes, and stars, and examine the chemical composition of distant worlds is opening up new avenues of exploration that were once thought to be impossible. The groundbreaking discoveries made by the JWST will have far-reaching implications, not only for astronomy and physics but also for humanity's place in the cosmos. As the telescope continues to operate, we are on the brink of a new era in space exploration, one that will likely lead to answers to some of the most fundamental questions about the universe, its origins, and our place within it. The JWST is not just a tool for looking deeper into space. It is helping to unlock the mysteries of existence itself.